Hello guys, in this video I'm going to be discussing the solution to the problem turtle and an infinite sequence that appeared in the Codeforces round 949 div 2. So in this problem statement they have mentioned that we have an array of infinite length. They won't provide us with this array. The array will be such that the aith value will be the equal to I. So I will be from uh, I is from I is equal to 0 to I is equal to infinity. So since it's an infinite length array, and for each value ai will be equal to I. Now we have to do some operations. They will specify the number of operations that we want to do. So suppose they give us m is equal to 1. We want to do one operation on this array. If they give us m is equal to 2, we have to do two operations on this array. And in each operation what we want to do is that we want to convert ai to ai minus 1 or okay, this is the bitwise OR operation. I am not saying we can take this or this. I am telling that we have to take ai minus 1 bitwise or ai bitwise or ai plus 1. So this will be the new value for ai, and since a0 doesn't have a0 minus 1 a minus 1, it will be equal to a0 bitwise or a1. So this is what we have to do, and we have to, and they will give us a particular value n. So we have to output the value of a n after performing these m operations. If they have given us m is equal to 0, we don't need to output we don't need to perform any operation. We can directly output cout n, since initially a n is equal to n. Yeah. So how will we solve this problem? So in this problem the major observation is that since ai can be only affected by its neighbors, initially ai will be only affected by its neighbor ai minus 1 and ai plus 1. So suppose I will write some I will write the neighbors a little more neighbors: ai minus 2, ai minus 3, ai plus 1, ai plus 2, ai plus 3. So initially ai will be affected by neighbors ai minus 1, ai plus 1. Similarly ai minus 1 will be affected by neighbors ai minus 2 and ai, right? And in that same operation ai plus 1 will be affected by ai and ai plus 2, right? So when we are doing the next operation on ai, so initially in m is equal to 1, ai will be only affected by ai minus 1 and ai plus 2. Even though in the second operation m is equal to 2, it will only be affected by ai minus 1 and ai plus 2. In the previous operation m is equal to 1, ai minus 1 got affected by ai minus 2 and ai plus 1 got affected by ai and ai plus 2. When we are doing the second operation, even though we are doing bitwise OR of ai minus 1 ai plus 1, it will be similar to computing the bitwise OR of all these values, right? Because like in the first operation this was affected by this and this, and this was affected by this and this. So the second operation, when we do bitwise OR of this and this, since already it was affected by this value, and since already this was affected by this value, it will be equivalent to taking the bitwise OR of all these values. So in the second operation it will be equal to ai is equal to ai minus 2 or bitwise or ai minus 1 bitwise or ai bitwise or ai plus 1 bitwise or ai plus 2. And similarly in the third operation ai will be equal to ai minus 3 bitwise or, so this the window gets expanded by one element, the number of the number of elements that ai gets affected by, the number of element that affects ai will get incremented by 2. So on the left hand side by 1 and on the right hand side by 1, the number of elements that affects ai will get incremented by 2 in each operation. Yeah, so after performing m operations, after performing so after performing m operations is equal to m, what will be the value of ai? The value of ai will be equal to ai minus m bitwise or ai minus m minus m plus 1 bitwise or ai till ai, then ai plus m ai plus m plus 1 ai plus 1 ai plus 2 till ai plus m ai plus m ai plus m. So from ai minus m till ai plus m, we are taking the OR of all the values, and that's what affects ai. So what is basically ai minus m? ai minus m will be I minus m, right, according to the initial condition, according to the initial value, and this will be equal to I minus m plus 1. Even though these values will change, basically what we are taking is the this index itself. Even though these values will get changed in the second operation, third operation, fourth operation, and so on, but these will be the values that will be mainly affecting ai. So even though this ai minus m plus 1 will not be equal to I minus m plus 1 in the mth operation, this will be the, if you think about it, this will be the value that will be going to affect the other. So this ai minus m plus 1 will be I minus m plus 1 or some value, but this some value we will obtain it from the other things. So there is no need to consider this other elements, so we don't need to consider this. So what we can do is that to compute the answer, what we will do is that we will find the left bound. The left bound is equal to n minus m. N is the value that they will give us to find the value after performing all these operations, and r will be equal to n plus m, right. Now we will iterate through all the bits of L. Now we will iterate through all the bits of L. If a particular bit is set, if the ith bit is set, since this L will be also, we will take the OR of this L for our answer. So if the ith bit is set in our answer also, the ith bit will be set. But if the ith bit is not set, we have to check whether any value exists between L and R such that its ith bit is set. If there exists some value between L and R such that its ith bit is set, then when we take the OR, the ith bit of the answer will get set, right? So if the ith bit of L is not set, we have to check for some value in between L and R where the ith bit is set. Now to effectively compute that, what I am gonna do is that, so I am gonna create a temporary variable, suppose check, and then I am gonna set the ith bit of L as set. So this is the operation for setting the ith bit. So initially the ith bit is not set for L, so now I'm gonna set the ith bit for L, and that particular value will be check, and I'm gonna now I'm gonna check whether this particular check value is less than R. This check value is less than or equal to R. If this check value is less than or equal to R, we have not exceeded our bounds. So okay, if this check value is greater than R, it means that we are using some value outside our bounds, right? Outside the elements that we are considering. That's not valid. So if this check value is less than or equal to R, we can set the ith bit of answer as well. But to find the, this may not be the optimal way to check. Actually, the optimal way to check will be setting the ith bit of L as well as unsetting all the bits lesser than I. Okay, now I will tell you why we are doing this. So suppose we have a value, okay, what value should I choose? Okay, suppose we have a value 5. What is 5? 5's 0th bit is set, first bit is not set, and second bit is set. Now if we want to check, okay, and suppose the R is equal to what should the R be? 12. Let L is equal to 5 and R is equal to 12. So now I want to check, so, and here this particular bit which is this bit, okay, I don't want to do that. I'll put it a small value for you to understand. Okay, for 5, this particular bit is not set, right? Now we want to see whether if we set this bit, it will exceed the bounds. So if we set this bit, what will be the binary representation be? The binary representation will become this, and what is the value for this? The value for this is 7. It exceeds the bounds. But if we unset all the bits that are lesser than I, so what are the bits that are lesser than I? Currently I is equal to 1. So the bit that is lesser than I is I is equal to 0. If we unset this, so if you unset I is equal to 0, then this value will become 6. That is 6 is lesser than or equal to 6, so it's a valid value. So we can, so from this we know that there is a value 6 that is lesser than or equal to 6, so we can set the this particular first bit in our answer as well. Okay, so yeah, that's why we are unsetting all the bits lesser than the ith bit. So if you unset all the bits lesser than the ith bit, it will not go lesser than L. It will remain still. It will remain greater than L, because we are setting a bit that are that are greater than, even if all the bits that are lesser than I are set. When we are setting this particular bit, this it will be greater than, it will be greater, this the value of this ith bit will be greater than the sum of all these bits. So there is no problem for that. But we can't unset any of the bits that are greater than I, because if we unset any of the bits that are greater than I, the value will go below L, and it will go out of our bounds. Okay, this is basically the solution. Now I will show you the code as well.
Okay, I will show you the code for the problem. The code for the problem is, okay, so we are setting the bounds L and R. L is N minus M and R is N plus M. Right. Now we are initializing a empty answer variable, and inside this increment variable, what I'm doing is that I will use this to unset all the bits that are lesser than the ith bit. So initially, suppose I is equal to 0. Uh, if I is equal to 0, uh, there are no bits before I is equal to 0, right? So initially, this particular value will be equal to 0. But as we are traversing through the bits, we will traverse through the bits one by one. When we are traversing through the bit, and when we see a set bit for L, when we see a set bit for L, we will add the value of that set bit to increment, so that we can use that to unset that particular bit in the future. So if the ith bit is set, so we are checking the ith bits of L, as I've told you. If the ith bit is set, now we are putting it into the answer, as well as we are uh, we are putting it into the answer, as well as we are giving putting it to the increment variable. The increment variable will be used to unset the bits in the future. And if okay, if the ith bit is not set, what we will do is that we will we have created a variable called check, and we will assign the value for the variable for check as the L, and setting the L and setting the ith bit of L. As well as we are uh, you know uh, you know we are subtracting the value of L till this particular ith bit. So inside this increment variable, the value of L till the ith bit will be stored. So when we are subtracting it, it basically means that we are unsetting or removing all the bits that was set lesser than I. And now we will check the value. If check less than or equal to R, we will add that to the we will add that particular bit to the answer as well. Yeah, this is basically my approach. If you understood the video, can you like, okay, if you didn't understand the video, that's the important part. Can you comment down below what you didn't understand, so that I can improve my videos in the future? Yeah, thank you. How should I stop this here?